We shall now discuss a few problems. The first problem is this. An alpha particle of charge 2e is hurled at the nucleus of a gold atom of charge 79e. Please recall that this is a Rutherford scattering experiment. Assume that the energy of the alpha particle is initially 4 MeV, million electron volts. For a head-on collision, calculate the closest distance of approach of the alpha particle at the nucleus of the gold atom. We shall now discuss the method of solving the problem. You have a gold nucleus and an alpha particle being hurled at it for a head-on collision. What's happening? Initially, the alpha particle is having a certain energy. The gold nucleus is at rest. This is a problem where the total energy is conserved. Follow the steps. The total energy is conserved. Initially, the gold nucleus is at rest, therefore no kinetic energy. The kinetic energy of the alpha particle is given in the problem as 4 MeV. MeV means million electron volts. 4 million, 1 electron volt is converted here into joules. The energy is now expressed in joules, and this is the initial energy. It is also the total energy because gold atom has no energy. Now the initial distance is very large. You see here the gold nucleus is here, the alpha particle is coming from a very great distance. So the initial distance is very large, practically infinite. So you can take the potential energy to be 0. Now in its approach, what happens? The alpha particle comes, remember that the total energy is conserved. The alpha particle comes nearer and nearer. The gold nucleus has a positive charge. The alpha particle also has a positive charge. Therefore, there is a repulsion. The alpha particle is now approaching, overcoming the repulsion. Therefore, it is losing its kinetic energy. Gradually, thereby, it is gaining its potential energy. So, initial distance is very large and therefore is 0, but in its approach, the alpha particle loses kinetic energy, gains potential energy. What will happen finally? It loses, gains potential energy, kinetic energy, half mv square finally becomes 0. The alpha particle comes to a stop and then reverses its motion, goes back. So finally stops, its kinetic energy then is 0, then it reverses its motion. At the stopping stage, all its initial kinetic energy has been converted into potential energy. So the total energy, which is also the potential energy, is now 4 MeV as mentioned earlier. And what is the expression for potential energy in classical physics? 1 by 4 pi epsilon 0 Q1 Q2 by R. You see, when it has come to a particular distance R, that distance, charge multiplied by charge divided by distance, also a proportionality constant. 1 by 4 pi epsilon 0, this is the charge Q1 of the gold nucleus, this is the charge of the alpha particle divided by the distance of closest approach. So this must be equal to 4 MeV, and what is 4 MeV I have written here. All you have got to do is substitute and calculate the value of R. That is not now a difficult problem, because 1 by 4 pi epsilon 0 is 9 into 10 power 9 standard values can be taken from tables, substituted and calculated. I would like to mention here the way in which I approach the problem. I am much more interested in the way in which a problem is analyzed rather than in the final number or a numerical value. Up to this stage, the problem is practically over in its method. Hereafter, it is only a question of mere substitution and calculation of a value.